Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting concept in the subject short range wireless communication. We're going to see the working of RF transmitter. We already seen the basics of communication in previous videos. Before starting the short range wireless communication, we have seen what is modulator, what are the different types of modulation, what is amplifier, what is frequency division multiplexing. All the basics is covered. Right now we're going to see how the modulator is going to work with the transmitter, what is the working of amplifier, what the transmitter will do, how we're going to transmit a message signal along with the carrier signal. All the things we're going to see in this particular video. So this video is about the working of RF transmitter. So when we say RF transmitter, you all understand what is transceiver. You understand what is transceiver, what is transmitter, and what is receiver. From the name itself you can understand transmitter is something which transmits the signal. That is the original signal. It will be transmitted by the transmitter, right? The device which transmits the original signal, that is called as transmitter, and the transmitted signal will be received by the device which is called as receiver. So the receiver is the one which receives the original signal, right? And there is another particular communication device which is called as transceiver, which will act as both transmitter and receiver. We have already seen an RFID working, how the RFID works, right? So you would have known what is transceiver. So transceiver is something it has the capability to transmit and as well as receive, right? And today we're going to see the working of transmitter, right? How the transmitter works. So as I said, transceiver is the combination of transmitter and receiver, and where it will convert the RF frequency to IF frequency. IF frequency is nothing but intermediate frequency, right? The original frequency will be somewhere, say for example, if it is 100 megahertz, right? Intermediate frequency will be below that, right? So the main purpose of transceiver is it will convert the RF frequency into intermediate frequency and intermediate frequency to RF frequency, so that if we convert to intermediate frequency, we can able to process that particular signal, right? And the main applications of RF transceiver is it can be used in satellite communication, radio communication, television transmission reception, and in all networks, that is WiMAX, WLAN, ZigBee, we can use transceiver, right? And now we'll see the working of RF transmitter. So this is the basic block diagram of RF transmitter. So where you have to explain each and every blocks. First I'll explain you the complete working of RF transmitter. So when we say RF transmitter, there will be original data, that is the source data. This original data can be an analog data or digital data, and also we can able to transmit analog signal into a digital signal, that is we can use analog to digital converter, right? Wherever we need a digital transmission, we can convert the analog signal into digital and we can able to transmit, right? So the source data can be either an analog data or a digital data, right? And the very important part here is modulator. I have already explained you what is modulator. Modulator is the one which performs modulation. That is, we will not be able to transmit the original data to a very longer distance. So in order to transmit the original data to a very longer distance, we need the help of modulation, where the modulation is the process of combining the message signal and the high frequency carrier signal. So this high frequency carrier signal will be generated by any of the oscillator, which we call it as RF source. So this carrier signal will be a high frequency signal, and that will be combined with the original signal, the original data, right? And that particular process is called as modulator, right? Technically speaking, we will superimpose the original signal with the carrier signal and we will transmit, right? So modulation, here it will combine the carrier signal and the original data so that it can be transmitted over longer distance. And now once the modulation is done, the modulated signal has to be amplified because it has to be sent to a very longer distance. So we need to have RF amplifier because we are using RF signal here. So the RF amplifier, what it will do is it will amplify the signal, it will boost the signal, and also it will reduces the noise to a certain limit, right? So it will boost this particular signal, suppressing the noise, and even if there is any unwanted spurious signal, because we use oscillator here, so definitely there will be some unwanted spurious radiations, the unwanted radiations. That radiation will also have the impact in this particular signal, right? And those signal has to be removed. So before it is transmitted to the through the antenna, we need a filter, right? We need any band pass filter, right? And that particular filter will remove the unwanted signals, the spurious signal, and will send only the desired signal, and that desired signal is sent through the antenna, and the antenna is the one which transmits that particular signal, right? And for all this particular components we need DC power. DC power is given to the transmitter, right? And very important part here is you definitely need a matching network here. I'll tell you what is matching network. We will see in depth about each and every components now. If you want to achieve the maximum power transfer obtained from the amplifier, right, that is the maximum signal which is transmitted, like whatever signal which is generated has to be sent through the antenna completely. Only if there is a successful matching between the antenna and the particular transmitter, only then the complete maximum power transfer can happen, right? So definitely there we need matching networks, right? So in order to obtain a matching network, we need to know the input and output impedance of the devices. We will see in depth about it, right? As of now you understand the working, that is the original data, it can be analog or digital, that will be modulated and then it will be amplified, and the amplified signal is filtered and then transmitted through the antenna. This is the working of RF transmitter, right? And as I said, the source data can be an analog or digital, and radio frequency carrier is obtained from the RF source, which is modulated and then amplified and then filtered, right? And when it comes to RF source, we have different versions of RF source, that is we can able to obtain the carrier signal, and the frequency control of the signal in short range transmitters is based upon LC. It can be a simple LC circuit, or it can be obtained using SAW resonators, crystal oscillator, frequency synthesizer, direct digital synthesizers, right? It's nothing but we can able to obtain the RF source from all these particular devices, right? And based upon the accuracy and stability, the version of the devices varies. That is, very initially we use the LC circuit where we can able to obtain the RF signal, right? But it suffers from a lower stability and accuracy, and to overcome that we have SAW resonators, which is surface acoustic resonator, where then we had crystal oscillators, which is predominantly used. Crystal oscillators has more stability than other oscillators. Like that, we can also use frequency synthesizer. What is frequency synthesizer? We can able to obtain more frequencies from one frequency component, that is called as frequency synthesizer. And very recently we use direct digital synthesizers, that is it can able to generate RF signal digitally, that is using softwares. So this is the different versions of frequency control in short range transmitters. It can also produce the RF source, right? And when it comes to frequency control methods, two important parameters is very important. One is accuracy and stability. Accuracy, you know that accuracy is the degree of deviation from the nominal frequency, right? Irrespective of any temperature or any particular condition, right? Whereas stability expresses how much frequency may change over the temperature or any other external condition, right? The system has to be stable, the device has to be stable, right? The operating condition must not change irrespective of temperature or any particular environmental factors. That is called as stability, right? And we will see in depth about frequency synthesizer and direct digital synthesis in separate video, but as of now you understand what is the use of frequency synthesizer in transmitter. That is, frequency synthesizer can able to generate RF signals, that is we can able to generate more frequency signals from one frequency component, that is called as frequency synthesizer. Say for example, we are using one crystal oscillator, we can able to manipulate, we can able to have different frequency signals from that particular crystal oscillator. That is called as frequency synthesizer. And apart from that, we have two other reasons of using synthesizers. One is the output frequency is directly from an oscillator without using multipliers, and also we can able to achieve higher deviation in frequency modulation than when directly modulating the crystal modulator. So these are the uses of frequency synthesizer, the reason why we use frequency synthesizer, right? And the next important part is the amplifier. And before amplifier, what we will do is we will combine this RF source and this data, the original data, and that is modulated, and that particular signal is amplified. When we say amplified, the amplifier can, the main purpose of amplifier is to boost the original signal, right? And it also, the main reason of using amplifier is to isolate this oscillator and as well as this antenna, so that it will reduce the proximity effects, and also to make up the losses from the spurious radiation from the oscillators, right? And very importantly, in order to achieve maximum power from this RF amplifier, definitely we need matching networks, right? If the matching is not there, then we will not be able to achieve the maximum power transfer. Then the signal transmission cannot be done very successfully. All the signals cannot be transmitted successfully, right? And in order to design the matching networks, we need the input and output impedance of the transistors, which is used in the amplifiers, and that impedance parameters can be obtained from the manufacturers, but those data obtained from the manufacturers are for linear conditions. That is, the amplifier is set to work for a linear operation, but in many cases, due to practical difficulties, in many cases it works in non-linear way. When it works in non-linear way, those data of impedance will not be accurate, right? So in order to obtain good matching, trial and error method is used, right? As I said, non-linear amplification is more efficient, but linear amplification is necessary, right? So in order to obtain the maximum power transfer, right, maximum gain power transfer, then we need a perfect matching network. For that, what we have to do is the amplifier, that in order to design a matching network, we have to know the previous stage of the output impedance. That is, this is the previous stage. Before the amplifier, we use oscillator, and after the amplifier, use filter or antenna. We are going to use matching networks here. Matching network is very important, so that the signal which is generated has to be transmitted fully, right? And that has to be done only if there is a perfect matching. So in order to obtain perfect matching, what we have to do, we have to know the output impedance of this particular oscillator, and similarly the input impedance of the filter, right, or antenna. Sometimes we will not use filter, we will directly connect the amplifier to antenna, but if you use filter, then we need input impedance of the filter, right? And only then a perfect matching can be obtained. So low power transmitter amplifiers have low impedance inputs and high impedance output, right? And maximum power transfer, that is, maximum power transfer can be obtained by reducing the spurious radiation, right? That is, maximum power transfer, when we say maximum power transfer, it is essentially determined by that spurious radiation, not only by the maximum power specification, right? So the spurious radiation is the unwanted oscillations that is obtained from this particular oscillator, right? And in order to remove those oscillations, in order to remove the spurious radiation, definitely we need a filter, right? So this harmonics radiated directly from the oscillator will be less than 20 dB, where definitely we need a filter to overcome that, so that we achieve the full allowed power. The transfer of full allowed power can be done, right? And you can understand what is spurious emission. The radiated signal outside the transmitter's assigned channel, that is the unwanted signal, that is called as spurious emission, right? And when we say filter, we can, in most of the transmitters we will use, in RF transmitters we can use SAW band pass filtering, right? Whereas this is an effective filter for transmitter, and it has enough pass band and very steep slides, and the very important thing is we can shield the oscillator so that it prevents the radiation from bypassing this particular filter. And apart from it, the properties are, it has insertion loss of several dB, and it has high input impedance and output impedance, and can be matched to a low impedance, usually 50 ohm. That is because in practical conditions we achieve this 50 ohm impedance for perfect matching, right? And SAW is surface acoustic bandpass filter that employs piezoelectric effect to convert an electric signal into an acoustic signal and from acoustic signal to an electric signal, right? That is about filtering. And then we have to know about the impedance matching. So what I have done so far is I have explained the working of RF transmitter, right? Whatever signal that is generated by using modulator, amplifier, that has to be transmitted successfully through the antenna, and for that we need a perfect impedance matching network. You can see this particular diagram where we have not used filter here. If you use filter, then it has to be like you have to know the input impedance of the filter to find out the matching network. So here you can see this is about the transmitter circuit, right? And this is the antenna where the matching has to be done between this particular device, between these two, right? And only if there is perfect matching, then we can able to obtain the best transfer of power between the antenna and the device, right? And if there is any impedance mismatch, then there will be a lot of distortions like signal reflection, power loss, there will be a decrease in efficiency, all those things, right? The receiver modules normally is designed in such a way that it offers 50 ohm input impedance, and similarly a receiver integrated circuits is also will have 50 ohm input, right? And degree of matching to a specific impedance, usually 50 ohms, can be expressed by a reflection coefficient. As I said, practically we use this 50 ohm impedance matching for perfect transfer of a signal, right? So this is about impedance matching. So when we say about RF transmitter, you have to explain about the complete working, you have to explain about the data source, the modulator, the amplifier, the filter, and at last you got to explain about impedance matching, right? And if the impedance matching is very perfect, then the transmitted signal can the complete gain, that is the gain of the amplifier will be maximum, the power transfer will be maximum, the signal will be, all the signal that is generated will be transmitted very successfully, right? So this is the working of RF transmitter. So today what we have seen is we have seen the complete working of RF transmitter. I believe this video will be very useful for you. Thank you, my dear students.